Welcome back to the deep dive. Today, we're shifting gears a bit, moving beyond the usual tools, the things you actually use to build automations.
Yeah, we're going deeper.
Exactly, right into the core infrastructure. We've been looking at sources focused on the enterprise architecture of the UiPath platform.
And this is really the critical stuff. We're getting into the engine room, you could say.
Yeah, the engine room.
Looking at stability, security, managing resources, how you actually deploy this stuff at scale. If Orchestrator is the brain, this is the nervous system holding it all together.
Okay, so our mission here is to pull out the key strategic points fast. Not just, what does this button do, but more like, what architectural choices really lock you in operationally. We want to give you that shortcut to understanding the platform's backbone. Right, let's dive in. First, big choice. Where does this platform actually live? Everyone talks cloud, cloud, cloud.
It's not always an option.
Exactly. So, what deployment strategy is, like non-negotiable if an organization has really strict security rules. Rules saying all data credentials, logs, the whole lot has to stay inside their own network.
Yeah. That specific requirement, it immediately points to one answer: the internal standalone orchestrator deployment. The sources are crystal clear here.
No wiggle room.
None. If compliance demands total internal data sovereignty, you just can't have external cloud pieces or anything hosted outside. It has to be on-prem.
Okay, that makes sense from a compliance angle.
Yeah.
But what's the trade-off? What's the strategic cost people need to understand when they go that route?
Well, the cost, it's the operational burden, isn't it?
Right.
Compliance might force the standalone choice, but suddenly you're responsible for everything. Patching, high availability, scaling, all the infrastructure maintenance, it's all on your team.
So you lose the ease of cloud management.
Completely. That's the hidden trade-off. You get total control, yes, but you also get total responsibility.
Okay, sticking with control. If we mentally strip away the developer tools like Studio and the robots doing the work, and we just focus purely on the infrastructure layer itself, the bits, handling stability, security, resources, what are the two core elements that form that absolute essential backbone?
That fundamental backbone, it's really two things. Orchestrator itself, obviously.
The conductor.
Right. And the identity management service, often called the identity server.
Identity server. Why is that so fundamental alongside Orchestrator?
Because Orchestrator manages the workflows and resources, sure. But the identity server, it governs the entire secure access layer. Authentication, authorization, it's key.
So Orchestrator conducts the orchestra, like we said, and identity server is kind of the platform security guard, the bouncer at the door.
That's a good way to put it, yeah.
Yep.
It handles who gets in, what they can do, validates tokens, secures user access across everything. If your identity server gets compromised, well, the whole system's vulnerable. That's why it's right there with Orchestrator at the core.
Okay, that makes sense. Now let's touch on something scary. Migrations. Security during migrations. If a company's moving, say, from an older standalone orchestrator to a new setup, what's the one critical security thing they absolutely must transfer correctly to make sure all their old data is still readable?
Oh, this is a big one. Probably the highest risk point in a platform shift, operationally speaking. It's the platform's core encryption key.
The encryption key. Why is losing that specific key so catastrophic?
Because UiPath uses that key, that one specific key, to encrypt all the really sensitive stuff in the database.
Like credentials.
Exactly. Credential assets, data in your queues, sensitive configurations. It's all encrypted with that key. So if you move the database to the new environment, but you mess up transferring or syncing that key, yeah, the new platform just can't read the old data. All your secrets, all your credentials stored securely, they become unreadable garbage. Your migration basically fails until you find and fix that key situation.
Wow. Okay, that definitely highlights needing good security practices before you migrate. Let's shift gears a bit now. Let's talk scale and resilience. Looking at the more modern deployments, specifically the UiPath automation suite, you hear about things like automated scaling, services that heal themselves, dynamic resource management. Sounds pretty advanced. What's the tech actually making that happen?
Right, that kind of advanced orchestration, that magic, it relies on a container-based cluster management system. We're talking Kubernetes, basically.
Oh, Kubernetes. Okay, that's a huge topic on its own.
Yeah.
But why containers? Why Kubernetes here? Why not just really powerful servers.
Well, the thing is, Automation Suite isn't just one big program. It's actually made up of lots and lots of small interconnected pieces, microservices.
Hundreds, maybe.
Could be. And Kubernetes is built to manage that kind of complexity. It understands how all those little services depend on each other. It shifts resources around automatically, allocates them where needed, and crucially, it provides fault tolerance.
Meaning if one little piece breaks.
Kubernetes spots it and restarts it automatically. Without someone having to manually intervene, imagine trying to track hundreds of services yourself. It would be overwhelming. Kubernetes handles that orchestration.
Okay, that puts the suite part into perspective. It's not just one thing. Now let's zoom in on high availability HA. For those multi-node orchestrator setups where you have several servers sharing the load, what two external things do you absolutely need for stability and maybe more importantly, to stop users getting booted out mid-session?
Yeah, for proper HA, you need two key external components working together. First, you need a network load balancer, an NLB, that spreads the user traffic evenly across your orchestrator servers.
Makes sense. Distributes the load. What's the second piece?
The second critical piece is a distributed caching system. Something like Redis is common.
A distributed cache, like Redis.
Yeah.
Why is that so vital for keeping sessions alive? Couldn't you just use the main database?
You could try, but database lookups are generally too slow for this. You need instant access to session state. The distributed cache provides that super fast temporary storage. Think of it like this.
Okay.
The NLB sends your user to server A. Then, server A has a problem and goes down. The NLB instantly reroutes the user to server B.
Right.
That distributed cache. It acts like a shared whiteboard or shared memory that both server A and server B were constantly updating and checking. So server B immediately knows exactly what the user was doing, where they left off, because it checked the cache. Session maintained, no data loss for the user.
Ah, okay. So the cache is like the short-term shared memory for the whole cluster. Keeps things smooth during a hiccup.
Exactly. Absolutely vital for surviving those inevitable server failovers without disrupting users.
Got it. Okay, let's talk about separation. Logical isolation. Big companies, right? They absolutely need to keep different departments' data and resources separate. Think HR versus finance. Can't have them seeing each other's stuff. How do you achieve that strict logical separation inside the one central platform? What features do you use?
Yeah, that segregation is crucial. You use the platform's built-in layers for this.
Yeah.
The highest level, the strongest fence, comes from using orchestrator tenants.
Tenants.
Right. A tenant is like a completely separate container. It has its own users, its own assets, its own logs, its own queues. It's a real hard boundary between, say, HR and finance. True data isolation.
Okay, so tenants give you that big dividing wall.
Yeah.
What if you need finer control within a department, like within finance?
That's where the second layer comes in. Logical groupings, or as they're usually called, folders. Folders let you organize things and set permissions inside a single tenant. So you use tenants for the big top-level isolation between business units, and then you use folders within those tenants to structure resources, manage access for specific teams, and control who can see or run what process.
Makes sense. Okay, if orchestrator is the brain and identity is the gatekeeper, the robots are the hands and feet, the nervous system doing the work. But that system's useless if the connection isn't solid and secure. Now, there's one issue that seems to pop up again and again in the sources. Robots failing to connect because of timestamp problems. What's the real underlying cause there? It sounds minor, but...
It sounds minor, doesn't it? But honestly, in a big enterprise setting, clock skew is probably the most common reason a brand new robot just won't connect securely. The root cause is incorrect time synchronization between the robot machine and the orchestrator servers.
Just the clocks being off. Seriously?
Seriously. But think about the consequences. UiPath relies heavily on timestamps being accurate for secure communication. When the robot tries to connect, it uses tokens, and these tokens have timestamps. If the time difference between the robot's clock and the orchestrator's clock is too big, even by a little bit...
Handshake fails.
Exactly. Orchestrator rejects the connection attempt because the timestamp looks invalid, potentially like a replay attack or something. The immediate fix is usually forcing NTP sync, making sure the clock's aligned, but the failure stems from that basic time sync being wrong.
Wow, okay, a fundamental detail with big impact. Let's talk another security layer. Certificates. Sometimes, maybe in a test environment, an engineer might use a self-signed certificate for orchestrator. If they do that, where specifically on the robot's computer do they need to import that certificate to stop Windows complaining and actually allow secure connection?
Right, good question. To get the robot's operating system to trust that self-signed certificate, you have to explicitly tell it to. You need to import that certificate into the local machine's trusted root certificate store.
The trusted root store.
Okay.
Definitely.
That tells the OS, hey, even though this certificate wasn't issued by a globally recognized authority, I'm telling you it's okay to trust it for this connection. That allows the secure SSL/TLS handshake to complete.
Got it. Now, thinking about scale again. Infrastructure teams managing hundreds, maybe thousands of robots. They're not sitting there clicking next, next, finish on every single machine, right?
Definitely not, no.
So how do they deploy the robot software efficiently across the whole company? Like using tools like SCCM or Intune?
The standard essential method for that kind of mass deployment is using the command line interface's silent installation mode.
Silent install.
Yeah. It lets the engineers script the entire installation. They can pass in all the configuration parameters like the orchestrator URL, connection details directly on the command line. No pop-up windows, no user interaction needed. It just installs consistently everywhere, which is exactly what you need for large-scale rollouts.
Okay, makes perfect sense. Finally, let's talk configuration for the workhorses. Unattended robots. When an engineer is setting up a pool of unattended robots using a machine template in Orchestrator, what two specific things must they allocate in that template to actually enable jobs to be scheduled and run successfully?
Right. For unattended execution via template, you need to define both the capacity and the identity. So two things must be allocated. Number one, the runtime license quantity, how many robots can run concurrently using this template.
Capacity. Got it.
And number two, the specific robot user identity. This defines the Windows credentials the robot will use when it logs into the machine to run the job, and therefore what permissions it has.
The identity and permission.
Exactly.
Got
You
it.
need both the license capacity and the user identity defined in the template. If either is missing, orchestrators simply can't assign and execute an unattended job using that template. All right, that's all the time we have for this deep dive. We really hope digging into this infrastructure layer helps you navigate your own automation journey.
Hope it was useful.
We'll see you next time.